Alright, so this is the second lecture in our Introduction to Statistics course. We already covered quite a lot of stuff last time, so if you haven't watched the first lecture, I suggest you go and do that. These are going to be 10-minute long summaries of the ideas that we learn in these Intro to Statistics lectures. So let's go on with it. A grasp of the sampling frame. Surveys are a form of systematic and standardized data collection from a well-defined population of interest. The survey is given to a sample and data is extrapolated to the population. Surveys are important as they can influence voter behavior and consumer behavior. Because if you think about, say, a YouGov poll talking about the probability of Scottish independence winning at the next referendum, Unionists may respond to hearing high quantities of those who support independence voting may turn out in droves specifically to stop them getting an independence referendum, because it can mobilize the voter base. The population comprises all individuals with variables of interest, while the sampling frame is the list of units in the sample who take the survey. Sampling frames can occasionally get a perfect match with the target population, but it is generally imperfect due to errors with the sampling frame. For example, using electoral registers to monitor electoral age of the population as the sampling frame is flawed, as a substantial number of people do not even register to vote, so they would not be included on the sampling frame. The sampling frame just being the electoral register, so how we're surveying people based on the population. These inaccuracies in data collection from sampling frames are referred to as a non-sampling error. So, the types of samples, we have representative samples, which are used when we want our sample to be similar to the structure of the general population, so it should have similar proportions of men to women, and etc. We have probability sampling, which is the sampling of individuals from the population so they are representative of the population at large. There are many types of probability sampling that we will go over soon. There are just simple random samples, systematic random samples, stratified samples, cluster samples, and multi-stage samples, all of which are probability samples. So, let's get on with it. Non-probability sampling is the selection of participants in a survey on the basis of convenience. For example, snowball sampling or purposive sampling. Simple random sampling involves all members of a sampling frame having an equal probability of being picked for the survey. For example, drawing names from a hat. Systematic random sampling is similar, but can be subject to bias, as it involves using a system to choose subjects from sampling frame. For example, surveying every second house on a street, what is their annual income. Now, that may not seem biased because it's using a obvious sampling frame based on like house number. However, it may be possible that houses with like the low numbers, they're going to be higher up the street. They may be larger houses than those you find at the end of the street. And obviously large houses are going to be inhabited by people with larger annual incomes, and this may give disproportionate results to like the rest of the population. Like you'd get a more proportionate example, if you were surveying everyone on the street, obviously you can't do that. So that's something you need to look out for with bias with systematic random sampling. Stratified random sampling involves dividing the sampling frame into subgroups and randomly selecting subjects from each subgroup. It is typically more proportionate than non-stratified sampling, as subgroups can represent variables such as gender in a manner which is reflective of the general population. Now, cluster sampling is a compromise of the hitherto randomized ideal, where units are split into hierarchies, for example, having firms and employees as separate entities in a hierarchy, with firms being higher than employees, then randomly selecting a firm and surveying the selected firm's employees. Selecting more clusters this way, so the clusters referring to the larger entity in the hierarchy, being the firm, it's going to increase the reliability of our results, because if you have more samples, you're going to be able to compare them, and your means are going to be more accurate, which is fairly obvious. You should know that already. Probability sampling continued. Finally, we have multi-stage sampling, which is where you sample a series of stages which may involve both clustering and stratification, and it is a design used on many large real-life surveys. It utilizes top-level primary sampling units and secondary sampling units to form stratification. You don't really need to know much about that. It's just something to keep in mind. It's another kind of clustering technique, using stratification as well, of course. So now we're going to have a look at non-probability sampling, and this includes quota sampling, which is where the sample is made proportionate to the general population by setting quotas for units with specific characteristics. For example, if 55% of the population is female, then 55% of the units selected in the sample should also be female to keep it proportionate. Then we have snowball sampling, which involves individual units in a sample contacting new units they know, which is useful when surveying a unit which is relatively rare and has rare characteristics. For example, a person is surveyed and they get their friends with the same characteristics to participate in the survey. So if we're going to survey transgender people, they make up a very small percentage of the population, so it may be difficult to find them with a generalized sampling frame, because say if we're using a national census, it's going to be hard to find them because they make up such a small percentage of the population. However, they likely know other people who are similar to them, because you tend to seek out people who are similar to you generally, and they can contact them, get them involved in the survey, and it's a way of getting the people with variables of interest to participate in the survey when those variables of interest are relatively rare. So when the response rate is high, it is more likely that the sample is representative of the general population. And this raw data collected from sampling can be converted into histograms, pie charts, bar charts, line charts, whatever you want. Really, it depends how you want to display the data. They can also be displayed in pictograms, which use scales of images to represent data, but these are flawed as their height is the only factor that represents the data similar to a histogram. The width of the image in the pictogram means nothing and may give people the wrong impression if they are disproportionately thick or thin. Conversely, the width of a histogram is based on the size of the category. So, for example, 0 to 4.99 or 5 to 9.99, that would show up on the histogram. The histogram I've got on the right doesn't correspond to the data, it's just a random one I got off Google Images to show you what they look like if you somehow forgot. But yeah, they're relatively straightforward, and basically histograms are much better than pictograms as their width directly represents the size of the category and the height represents its frequency, whereas using a pictogram the width isn't representing like the size of the category and its height is the only thing like similar to the pictogram displaying the frequency given a particular scale. So obviously since the histogram displays more information as its width actually means something, I would probably say it is a better model to use. But obviously that's up to you. So that's it for the second lecture. These first two have been relatively like me talking quite a lot and very little maths. That will probably change quite a bit in the next few lectures where we're going to have a look at mean, median, mode range, and quartile range. Z values, don't worry if you don't know what they are, we'll go over it when we get there.